Okay, more integration. The trapezium rule with 4 strips is used to estimate the integral from -2 to 2 of square root 4 minus x squared dx. And what's the positive difference between the estimate and exact value of the integral? Okay, so let's start from the estimate then. So of course we need to chop into 4 strips. So the 4 strips will have boundaries -2, -1, 0, 1, and 2. Yeah, every comma is 1 strip. Every comma is 1 strip. Okay, so let's have a think. What is f of -2? That's 0. F of -1 is how many? F of -1 is square root of 3, is it? F of 0 is 2. F of 1 is square root of 3, and f of 2 is 0 as well. Okay, so trapezium rules. So what's the interval? And the interval is 1, so 1 over 2 times what? Times the f of -2, which is 0. Let's just sub in the value straight away. I'm sure you know the formula for trapezium rule anyway. So 0 plus 2 lots of the middle plus 0 again outside. Okay, so what does that give me? So the 1/2 cancels with the 2 there, so it gives me 2 plus 2 root 3. Happy? That's my estimate. All right, remember that's my estimate. Okay, now we come to the exact value of the integral. So how do I integrate this? There's a function inside the square root. All right, and it's a very common function that we see in integration. What's the substitution? The substitution is x equals to 2 sine theta, yeah, or 2 cos theta. I think both work, but I prefer 2 sine theta. Okay, so why is this good? Because dx equals to 2 cos theta d theta, and then the substitution is pretty straightforward. So, of course, we have to change my boundaries. So what's my theta now? When x is -2, my sine theta has to be -1. So I will be on -pi/2. Yeah, same logic for the top. So when x is 2, what's my theta? So I need to make sure that my sine theta equals to 1. Yeah, and therefore my theta would be pi/2. All right, and then sub in the rest. Okay, so this would be square root 4 minus 2 sine theta squared, and then 2 cos theta d theta. Okay, the rest shouldn't be too bad, I hope. So now the square root is very nice, yeah, because inside you can use a trig identity to solve that. All right, so the inside becomes 2 cos theta as well. So 2 cos theta times 2 cos theta d theta. Okay, and then now this will become 4 lots of cos squared theta d theta. All right, I hate to make you guys see me the algebra, but then you know how to integrate cos squared. Yeah, you use the cos double angle formulae. Okay, I'm going to multiply the 4 into that formulae as well. So you would have, what is it? 2 plus 2 cos 2 theta. Yeah? So remember, the cos squared theta is equal to half plus half cos 2 theta. Yeah, it's good to learn these. And also the sine squared theta version is a half minus half cos 2 theta. Yeah, very important and very useful in integration. All right, so when you see cos squared or sine squared, you use the cos double angle formula to integrate them. All right, so, and then you would see this is 2 theta. Okay, I can't integrate. What's this? Plus sine 2 theta, I think. All right, and with the boundaries as well. Okay, so when I sub in the boundaries to the sine, it's literally 0, so nothing happens. But when I sub in the boundaries to the theta, it gives me 2 pi, I think. Yeah, because when I sub in pi/2, it gives me pi, and then when I sub in -pi/2, it also gives me pi. All right, so in total, it's 2 pi. Okay, and it's asking for the positive difference, did it say? Yeah, it's asking for a positive difference. So what do I do? So I would go 2 pi minus 2 pi minus that thing. All right, 2 pi minus 2 plus 2 root 3. Okay, so it seems like they factored out the 2. All right, so the final answer would be B. Yeah, they factor out the 2, and you just play a subtraction. Oh well, there we go.